Hi there! Equations of a line, also known as the Spiderman by the Pi. So in this video, we'll be tackling more about the line, how to represent it in terms of an equation, and an immediate consequence of that one is determining when a line is parallel or perpendicular just by looking at its equation. So without further ado, let's begin. There are four main forms of an equation of a line. The first one is the slope-intercept form. It is given by y equal to mx plus b, wherein m out here represents the slope and then b out here represents the y-intercept. So if you don't know, the y-intercept is, graphically speaking, it would look something like this. So given a line, the y-intercept is the point wherein our line intercepts the y-axis out here. To obtain that one, all you need to do is to set x equal to 0. And once you set x equal to 0, you can easily determine the point wherein our line hits or intersects the y-axis. So next one, we have the point slope form, which is given by y minus y naught or y sub 0 equal to m times the quantity x minus x naught. So we can use this form when we have the slope and when we have a point on the line with the coordinates x naught, y naught, and this can be any point on the line. In particular, if this point in the line is the y-intercept, we just fall back to this one out here. So after that one, the next is the 2-point formula, which is given by y minus y sub 1 equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 times x minus x sub 1, wherein the points x1, y1 and x2, y1 must be distinct points on the line. So if you didn't notice it, take note that the 2-point formula just came from the point slope formula. We just represented m in terms of its equation with the rise over the run formula. Also, take note that y1 and x1 out here can be chosen instead to be y2 and x2 respectively. It doesn't really matter, you'll get the same answer. And then also, take note that you can interchange y sub 2 and y sub 1 out here as long as you interchange x sub 2 and x sub 1 out here. Since if you can imagine it, if you interchange them, the negatives would just cancel out in the numerator and denominator. Lastly, we have the general formula, which is given by ax plus by plus c equal to 0, wherein a, b, and c are real numbers, and a, b is not equal to 0 at the same time, because if they are equal to 0 at the same time, then we just get a constant equal to 0, and that is not really good news, since that isn't an equation. Take note that the general formula can be obtained from the three equations out here. All you need to do is to isolate everything to one side to leave the other side to be 0. Just one more thing to take note out here, there are also different forms of the line. There's also this thing called the 2 intercepts form, but it just really falls under the 2-point formula, so I didn't put it out here. We also have the vertical line and the horizontal line. For the vertical line, its equation is simply given by x equal to a, and then for the horizontal line, we have y equal to b. So graphically, you can easily see why this is true, since if it is x equal to a, so if this one is a, then the line just passes through this one, takes any y value, as long as its x coordinate is a. The same idea applies for y equal to b. So I didn't put it out here for two reasons. One, there's a lack of space out here, and two, we won't really be using this formula in our problem, so we don't really need that one. Also, if you are wondering, for the proof of these equations, I'll just leave this as an exercise, but all you need to do is to start with the formula m equal to y minus y sub naught over x minus x sub. So this is essentially the formula for the slope, wherein in this case, x naught, y naught is a point on the line, and then the coordinates xy, for the point xy, this one, is represented by any point on the line that is distinct from x sub 0, y sub 0. So that would be your working equation in solving for these forms of the equations of a straight line. So take note of this one. And yeah, again, as mentioned earlier, an immediate consequence once you have this is determining whether two lines are parallel or perpendicular. So we state them formally in a theorem. So given two distinct lines L and L prime with slopes ML and ML prime respectively, we see that these lines are parallel, denoted by this symbol out here, if and only if their slopes are equal. And this kind of makes sense graphically, because suppose otherwise, like if we have two lines and their slope are kind of different, even just for a little, let's say this one is just like this, then we know that if their slopes are different, then at some point they would intersect. But if they are the same, then they won't really intersect in any way. On the other hand, these two lines are said to be perpendicular, denoted by this symbol out here, if and only if the slope of the first one is equal to the negative reciprocal of the other. If you're wondering how to obtain or prove this theorem, I will put a link in the description down below, since this one is kinda technical, and how to prove it. There's some technical stuff that you need to know in advance, so I'll just be leaving that as an enrichment exercise for you that you may check in the description down below. Yeah, so with that out of the way, let's now try out some examples. So first, our goal is to find the equation of the line L, wherein L is the perpendicular bisector of the line segment with endpoints A given by 2 and 4 and B given by the coordinates 6, negative 8. So this one is kind of scary at first, but let's first deal with what we have. Since our goal is the line L, and we know that this line is perpendicular to the line containing these points, it would be nice if we first determine an equation of the line for these 2 points. As I said, the equation of the line AB is given by, so in this case, we can use the 2-point formula since we are given 2 points. So it is given by y minus negative 8 equal to, this one represents the slope, it's the change in the y's all over the change in the x's times the quantity x minus 6. So take note that in this case, I chose the point B to be represented out here. You can also choose the point A and you'll get something the same. So simplifying this, we'll obtain y equal to negative 3x plus 10. So far we have this line out here. And once you have that, again, since we know that the line L, our desired line, is perpendicular to this line, then by our theorem earlier, all we need to do to determine its slope is just obtain the negative reciprocal of this. So note that the slope of our desired line L is given by 1 over 3. So again, the reason here is the theorem earlier. So far we know that the line L will now look something like either this, or this. We just don't know which one of them. Fortunately for us, we also are given that this line is a bisector of the line segment AB, which means that this line must intersect this one somewhere here in such a way that this one would be equal, since it is a bisector. When will that happen? That will happen if our line intersects the midpoint of A and B. So we solve for that one. Take note that the midpoint of the line AB, actually this one should be line segment. Just take note of that correction, is given by the point 4, negative 2. I'll just leave that to you to verify. All you need to do is to use the formula. Take the average of this one to obtain 4. Take the average of negative 8 and 4 to obtain negative 2. And then once you have this, we are done. We can now form the line L, since we have the slope and a point in it. So using the point slope formula, we obtain the line L given by y minus negative 2 equal to 1 over 3 times x minus 4. So it is represented by this blue line out here, a line perpendicular to AB, and it passes through the midpoint M so that these two are equal. So that is the answer for this problem. It kind of looks scary at first, but once you understand what's going on in the problem, it actually becomes easier. Let's move on to the next one. So here our goal is to find an equation of the line L1 in general form that is parallel to the line L2 with equation 3x minus y plus 1 equal to 0, and whose x-intercept is also the x-intercept of the line L3 with equation 2x minus 3y plus 6 equal to 0. So how do we solve this one? Again, our goal here is an equation of the line L1. Our first ingredient out here is that we know that it is parallel to this line L2 with equation 3x minus y plus 1 equal to 0. So it would be nice if we can write the equation of L2 in terms of its point slope formula, so we could easily determine the slope. So observe that 3x minus y plus 1 equal to 0 when written in the point slope formula is given by y equal to 3x plus 1. All we did is just move this negative y on the other side. Once you have that, this one is in the point slope formula, which means the slope of the line L2 is given by 3. So the slope of L2 is 3, and take note that there is a gap out here, since this is not just the slope of L2. We also know that L1 is parallel to L2, which means that by the theorem earlier, the slope of L1 must also be 3. So we now have the slope for our desired line. Our only problem is probably the point, and that is correct. We use the second ingredient in the problem. We know that the x-intercept of our desired line is also the x-intercept of the line L3 given by this equation, which means that in order to obtain a point on our desired line, all we need to do is to obtain the x-intercept of L3. So we solve for the x-intercept of L3. So to do that, you just set y out here to be 0. And then once you have that, this one will be 0. Simplifying, it can easily be shown that x is equal to negative 3. So this means that the x-intercept of the line L3 is negative 3, 0. So it is a point on L3. And not only on L3, because we know that this point, this x-intercept, is also the x-intercept of the line L1. So this one, negative 3, 0, is also a point on L1. And once we have that, we are done, since we now have a slope for L1, which is 3, and a point on L1, which is negative 3, 0. So by the point slope formula, we have the equation y minus 0 equal to 3 times the quantity x minus negative 3. So 3 out here is the slope. The coordinates is the point negative 3 and 0 out here. Simplifying and writing it in general form, we will obtain 3x minus y plus 9 equal to 0. And that answers the given problem. Let's move on to the last one. So for our last problem, our goal is to find the values of C that would make the lines 8x plus 3y minus 4 equal to 0 and cx plus 4y minus 1 equal to 0 parallel and perpendicular. So take note that what I mean by here is not parallel and perpendicular at the same time, since that is impossible. But what I mean here is to determine the value of C that will make these two lines parallel and another value of C that will make these lines perpendicular. So since we want to use the theorem earlier, then it would be nice if we first write this given equations into their point slope formula. So we begin by rewriting the given equations as y equal to negative 8 over 3x plus 4 over 3 and y equal to negative c over 4. There's a typo out here. There must be an x out here. So we just take note of that one, plus 1 over 4. So once you have that, we can easily determine the slopes of these two lines. So the slope of the line L is given by negative 8 over 3 and the slope of the line L prime is given by negative c over 4. Again, there's an x out here. So for these two lines to be parallel, then we know that their slopes must be equal. Or in other words, negative 8 over 3 equal to negative c over 4. Simplifying, you can easily obtain that c is equal to 32 over 3. That's pretty straightforward. On the other hand, for L and L prime to be perpendicular, their slopes must be equal to the negative reciprocal of one another. What I mean by that is negative 8 over 3 must be equal to the negative reciprocal of negative c over 4. That would be 4 over c. And then solving for c out here, you can obtain that c is equal to negative 3 over 2. Which means that the two lines would be parallel if c is equal to 32 over 3. And the two lines will be perpendicular if c is equal to negative 3 over 2. That answers the given problem. So those are our 3 problems for this video. So just a final word out here. So if you haven't checked it, please help me provide better math content to you by answering the Google form in the description down below, or maybe the comment section down below. It's just 3 questions asking you what you liked about this video, what you disliked about it, and things that you want to see in this channel, in this series, and videos regarding math in general. If that's too hassle for you, you can just comment it down below and I'll be glad to read that one. So that's it. I hope you enjoyed that video. That's it. That ends the video and have a nice day.